It's a beautiful Friday afternoon. It's been kind of miserable weather over the past couple of days. It's been very overcast and kind of that point where it's not really cold, but it's not really warm, and it's just kind of meh. So this is going to be a very pretty day for a walk. This time I'm going to take a right up ahead rather than a left and go towards the hydroelectric power station. It's a very cool view there. It's kind of no motor vehicle access across the Rhine on it, but it has a bicycle path and a pedestrian path, which is very nice. And we've got some fall colors out and the view of the Black Forest, or a little bit of it as well. But I did want to talk about GLP-1 receptor agonism, and this is something that people are probably more familiar with than they think. I think most people have heard of Ozempic, semaglutide, Wegovy, and that is one example of a GLP-1 receptor agonist. But to sort of set the context, for the broad umbrella term of receptor, it's basically just a protein on the cell surface that binds to something that's outside of the cell and then does something inside of the cell. So a very, very big umbrella term. The thing that binds to a receptor is called a ligand. It's just the word for a thing that binds to a receptor. When I was an undergrad back in the mists of ancient time, they had this lock and key model for receptors and ligands, where you had a receptor that was like a lock and you had a ligand that was like a key, and it slots in and things happen. Now they've got a model that's more about sort of conformational change, whereas the receptor and the ligand approach each other, they start to change their shape and match each other, and that sort of the change in the shape is integral to transducing the signal. So, and cells have a lot of receptors on their surface. Basically every cell is just coated with receptors that do all kinds of things. It's kind of how the cell knows what to do and how to act and what's happening all around it. And because we are not intelligently designed, the receptors that we have, generally there tend to be classes of them because they've been sort of duplicated in weird ways, and then there are receptors that are the same receptor that do different things on different cell types. And so the GLP-1 receptor is an example of a class of receptors called G-protein coupled receptors. And they're called that because they are coupled to G-proteins. G-proteins are a type of protein that bind to these class of receptors and transduce the signals through cyclic AMP, all of this molecular biology, fun stuff. They also signal through a separate pathway called the beta-arrestin pathway, and this one will become relevant as I keep talking about this receptor. So when you have the GLP-1 receptor is so called because it binds to a peptide called GLP-1. Peptide is a very small protein. Basically, you have proteins that are kind of big. They can be anywhere from big to gigantic in the general scheme of things. They fold up, and they have secondary structure and tertiary structure as they fold up. Peptides are much shorter. They don't fold as much. They're just very small proteins. So GLP-1 is a peptide, stands for glucagon-like peptide 1. And is made by cells in the gut. Basically, intestinal cells make this peptide in response to what you eat. And this peptide has a very short lifespan. It's minutes and it's gone. It gets degraded very, very quickly. So it was very difficult to sort of use this as a therapeutic, even to study it, given how quickly this peptide was degraded. However, one big stride in sort of understanding the biology of GLP-1 was finding that there was a sort of an extended life analog of the GLP-1. Basically, it acted exactly like GLP-1. It bound to the same receptors as GLP-1, but it had a longer half-life, and it was discovered in the saliva of the Gila monster. So that was kind of unusual. It's called Exendin 4. and it has a half-life of hours instead of minutes, which is still pretty short, but it was long enough that you were able to actually do things with it. And it was actually marketed as a drug, so a synthetic version of Extended-4 called exenatide was basically the first of this class of GLP-1 receptor agonist drugs, broad class called incretins. So there's a lot of work done around trying to make, kind of more stable, longer-lived agonists of this GLP-1 receptor, and I'll go into, why you would want that and what it does. But there were some big strides made with one called dulaglutide, and then of course the one that is most well known at the moment, semaglutide, which in its type 2 diabetes formulation is called Ozempic, and its weight loss formulation is called Wegovy. So what does this do? So when you activate this receptor, if you look at where it's expressed, so if you just kind of look at a tissue map where you have the tissues in the human body on the x-axis and you have expression levels on the y-axis, you can see it's like pancreas, heart, saliva. So it's expressed at screamingly high levels on the pancreas, and it's expressed on all three cell types in the pancreas. So when you're dealing with the cell types in the pancreas, there's alpha cells, beta cells, and gamma cells. And the beta cells are the ones that are kind of the big players. They are the ones that make insulin. So these are the cells that if you have type 1 diabetes, they're attacked by the immune system, they're killed off and they can't make insulin anymore. That's the reason for type 1 diabetes. In type 2 diabetes, as your cells are becoming resistant to insulin, these cells are working very hard to make more and more and more and more, and they run out. They eventually kind of die off, from all that stress. So if you bind to GLP-1 receptor on these beta cells, what happens is that it increases their proliferation, it decreases the programmed cell death, called apoptosis, and it increases their ability to secrete insulin. So basically, it's everything good for those cells. They restore themselves better, they don't die as much, and they work more efficiently. It also has some effect on the alpha cells with their make less glucagon, and gamma cells making more somatotropin, and these have some other effects as well on sort of delayed gastric emptying, keeping you full for longer, feeling full for longer, satiety. And that's kind of where the use in type 2 diabetes comes in, is that it really helps bolster your body's own natural ability to regulate its blood sugar, which is a good thing. Now, I mentioned that it was expressed on some other cells in the body, and that's where things start to get interesting. So I mentioned it's expressed in the heart. It's expressed on these cells called cardiomyocytes, and it's sort of a class effect that these drugs have cardioprotective effects, which is even beyond sort of when they mediate weight loss, that has some cardioprotective effects. These have additional cardioprotective effects. And of course, there's the whole weight loss, which these are drugs kind of have revolutionized the whole field of. And the question now is, what cell types mediate the weight loss? Because of course there are some effects on the alpha cells and the gamma cells in the pancreas that affect that, but this receptor is also expressed in the intestine. It's expressed in certain parts of the brain, and it's expressed even in adipose tissue. So it's got a lot of expression that is at lower levels than in the pancreas. And the question is, of course, exactly which areas are most important for mediating the weight loss, because what I mentioned, there are these two different formulations for semaglutide, for instance, the Wegovy and the Ozempic. And the Wegovy, which is the weight loss dosing, is higher than the type 2 diabetes management. So there's also some sort of ex vivo, some work in cell lines and such, that suggests that the expression level of the GLP-1 receptor affects the potency of an agonist, so whether the natural agonist of GLP-1 or whether one of these synthetic agonists, the density of the receptor affects how much of the compound needs to get to it in order for it to mediate its effects. And so that's why it becomes rather an interesting question as to what parts of the body you need to most affect in order to get the weight loss going. whether it needs to be the brain, whether it needs to be the intestine, whether it's a combination of some of these, and if so, like which one is the limiting factor, which one's the one that you really need to hit. And so, you know, that's kind of where where I work. I'm a biomarker scientist, and I kind of look at sort of downstream effects of these receptor agonists on various different cell types in order to try to sort of tease this apart. And I mentioned, so semaglutide is kind of the one that's out there at the moment, but there's a bunch more kind of coming up the pipeline, as it were, from a bunch of different companies, and some of them are a little bit, you know, longer lived. Some of them are dual agonists that also affect other pathways, but a lot of them are what's called biased agonists. So I mentioned, you know, the G protein coupled receptors have this sort of G protein signaling. They also have this beta-arrestin signaling. And there's a lot of kind of discussion around the contribution of each of these pathways to sort of the negative effects, which, you know, I haven't gone into, but I think everybody's pretty familiar with the negative effects of semaglutide. You have nausea, vomiting, diarrhea, you have basically gastrointestinal issues. But one thing that is absolutely clear is that beta-arrestin mediates downregulation of the receptor. So basically the receptor gets pulled in from the cell surface and it's no longer available for signaling. And that kind of limits the ability of the GLP-1 receptor agonist to mediate the positive effects. And so you have these biased agonists, and this is where I mentioned the sort of conformational change. You can actually affect the signaling pathways more or less depending on the nature of that conformational change. So they have these agonists now that are in development that preferentially go through the G protein, and that go very little through the beta, have very little activation of the beta-arrestin pathway. And what that means is that the GLP-1 receptor is on the surface for longer time and has more of an ability to mediate its protective positive effects. So that's kind of where things are. There's, kind of extended duration for longer dosing are things that people are working on. Orals are things that people are working on. But I think there's a lot of really interesting biology in terms of all of the effects that these agonists can mediate. And I think it's a very exciting and interesting place to be, where we can really learn a lot more about the biology of obesity, metabolic syndrome, all of this stuff. Because, we evolved like way even before humans. Almost the entire history of evolution of living creatures has been in a context of scarcity, where there's food is sort of limiting, where there's a lot of competition for food, and therefore we are very much evolved to be fat. We have incredible pleasure responses to food because it's so very evolutionarily advantageous to seek out high calorie foods in order to kind of offset the scarcity and make it a priority to get that food. So, and now of course, since the agricultural revolution, there are certain places where sort of developed world is, I guess, the right way to put it, where it's suddenly, like a light switch, it's suddenly disadvantageous to acquire food quickly because it's no longer scarce. But anyway, that was just kind of my rambling for the day. I really like the work that I do. I really like talking about it. It's exciting. And, this is really a beautiful area to talk about it. We have all of this fall color now, especially, which is very, very nice. So just to my left there is the Rhine. Let's get a little closer. And so you can kind of see, we'll be going on to it, but you can kind of see the power plant over there. And this is the locks right here. Actually, I think I can walk down to it. Man, it's such a nice day. It was just so kind of blah over the last week. And now you get this nice sun. The autumn festival, the Herbstmesse, is going to be starting tomorrow on Saturday. Oh, nope, can't go there. You get to see the stairs again. it's going to be starting on Saturday, and that's always a great time. They do a good job with having these festivals that are very kind of cheery and exciting and get people out and into the open air as the days are getting very short and it's getting very dark, you know, to have this sort of bright, happy, fun festival. And then once the Arab semester closes down, there's a little bit of a gap, and just as you're starting to get depressed again, the Christmas markets start up again, which once again are very cheerful and colorful and bright and lots of people out and about, and they have a slightly different, well, not a slightly different, it's a fairly different sort of vibe from the autumn festival, in terms of the autumn festival's got a lot of rides. And the markets, of course, are the markets. They've got a lot of shops. And of course, there's a lot of food and drink. Glühwein, which is the spiced wine. It's really, really nice. But so that you don't get kind of burned out on the Christmas markets, because the autumn festival is different enough. And then, of course, the New Year starts, and it's February, which is very, very depressing. But then there's the carnival, which is another cool thing that they have. Lots of floats, drum corps, music, pantomimes. It's great. So these are the locks. Oh, we might actually have a ship in the lock. Some of these barges are so huge, you're like, how does it even fit in there? Yep, there's a barge in the lock right there. And you can see, you know, so you can see the barge with the containers and how close it is on the sides here. Oh, I think it's coming this way. Yeah, it's absolutely wild. They use the Rhine for transport, you know, of just container ships. They have trash barges. They have pleasure cruises, that sort of thing. And this is downstream, so this container ship is going downriver. And that dude is closer to the edge than I'd be comfortable being. Getting trapped between the two. Yeah, no, that's cool. You usually don't get to see that. At least I don't. And over there are the Roche Towers, I think I mentioned before. They kind of dominate the skyline. And this is a park that they have off to the right. It's sort of a city park where they have this sort of set of cafes that are built off of old caravans, transporters, that kind of thing. It's very cool. In the summertime, they string up lights and they party and drink until wee hours of the morning. And nobody lives around here, so it's fine. Nobody cares. They also have here for Swiss National Day, Basel has its own celebrations, but Birsfelden has its own celebration where they have a children's parade at nighttime, and the children have these big torches that they carry around with drum corps in front of them. That's very nice. So this is the Swiss power plant downriver. Once the Rhine flows through, the Rhine flows through Basel, and then goes to France. And there's a French hydroelectric power station a little ways down the river, but this is the Swiss one. And as you can see, this is just a place where people gather, hang out. It's got parks on either side of it. There's a good collection of third spaces. Yeah, these two. Sorry, that was a little loud. They have those urban sweepers in Basel, but they're electric and they're incredibly quiet. A lot of times when I'm out for a run, especially on a Sunday morning, you'll see those things cleaning up all of the debris from Saturday night parties and such. And whenever they have a parade, so they have big parades for Swiss National Day with a lot of horses, and you'll see those those things, the electric ones that are quiet, going after and just cleaning up all the horse poop. It's really cool. Oh yeah, you can actually sort of see the Ferris wheel up at the Münsterplatz. That's always the first thing I go to for the Herbstmesse, because it just gives you this wonderful view of the city. You can see all the way into Germany and France. Not that that's very far, honestly. Germany's just up ahead and on the right. Actually, it's fair ways to the right. Basel kind of sticks up into Germany and France like that. And this is a place where the Rhine's a bit bigger and wider. It narrows up a little bit when it goes through Basel. And the current is very strong. I've done the floating, and then when they had the triathlon was in the Rhine, the swimming part of it, and that current is no joke. So let's see if any of the sluice gates are open. Might not be. You get a lot of those little two-stroke motorcycles. They are allowed on the bicycle paths. So yeah, that's the Black Forest. You can see once a little piece of it. You can see the fall colors. Yep, now the gates are open today. That bridge down there is the one that I went on the last walk, and that's the one that I take into work every day. Yep, no big cascading sluices of water today, unless maybe it's at that last one. Chains. I'm a big fan of big machines, big chains. 10-year-old boy at heart. Yep, not today. But anyway, I wanted to go on a little walk, enjoy the autumn sunshine and the autumn colors, and ramble a little bit about some of the biology I find interesting. Now I gotta go do some errands, but I'm glad I was able to bring you along today.